from second year of mechanical engineering from SRIT college. Today I want to discuss about manufacturing process in the topic blanking and piercing force and power equipment in this operation deep drawing. Let's start. Introduction to blanking and piercing. Blanking and piercing are the essential metals forming operations used in manufacturing. They involve the current process that creates the specific space or holes in metal sheets. Understanding this process is crucial for efficiency of production of a material uses. Blanking and piercing is done in the material of the metal steel. You can observe how the blanking is done with the metal steel process in the figure by the right side diagrams. How the blanking is done and piercing will be done with the material. What is blanking? Blanking involves the cutting out a flat shape from the sheet of metal. The cut out piece, known as the blank, is used for the further manufacturing process. This operation is often performed using the hydraulic pressure or mechanical press wheel. By using of the steel, steel metal, we can placing the object in the hydraulic pressure or mechanical pressure wheel and presses the material. We can with the shape we can see the right side how the blanking will be done and it will use for the further materials by the blanking process. What is piercing? Piercing performs to creating a holes in the metal steels without removing the entire piece. These materials removed during the piercing is known as the slab. These operations is commonly used to making a part like blankets and connectors. Difference between blanking and piercing. The main difference lies in the final product. Blanking product is a part of while piercing creates a hole. Blanking typically has a large cut area than piercing, which focuses on smaller openings. Both process requires different tools and operation setups for the efficiency. Material considerations. This choice of the material affects the blanking and piercing process significantly. Material like steel, metal, aluminum, copper, steel may affect the differential for the cutting forces. Understanding the material properties is virtual for the prevent difficult during the operations. By the using of the steel or aluminum or copper materials, we can able to do the blanking or piercing process in the hydraulic pressure machine or the hydraulic flywheel. Forcing in blanking and force in blanking and piercing. The cutting of force in blanking and piercing is determined by material thickness and types. Shear strength and the material plays a crucial role in the calculating the required force. Proper force applications ensures clear cuts and the reduces the tool wears. You can see the blanking and punching in the right side in the figure. Blanking, and this is a scap, this is a workpiece after the cutting by the in the machine. Power requirements. Power requirements are the influenced by the speed of and the size of the operations. Higher power is needed for the thicker machines and the larger blanks are piercing. Understanding the power needs helps in the selected applications machinery of for the tasks. Tools for blanking and piercing. Tools included dies and the punches for the specific shapes and the holes. Proper tools sign enhances the efficiency and accuracy of the operations. Regular maintenance of the tools is essential to ensure the long term of the performance of the tools of the blanking and piercing. We have to maintain the proper maintenance for the tools where we use in the machines. And what is the advantages and of the blanking? The advantages of blanking: higher precision, efficiency, material utilization, stability, smooth edges, and cost efficiency. And piercing: high speed, accuracy, multiple hole creations, minimal distortions, and compatibility and integration with the other process. Limitations of blanking and piercing. Limitations included the necessity for the precise tools and the setups. Material restrictions by may affect the choice of blanks or precise components. The operations may not be suitable for every complex shapes or designs. Introduction to deep drawing. Deep drawing is a material forming process used to produce hollow spaces, hollow shapes. These operations involves the stunting a material sheet into a cavity using a die. It is a commonly used to manufacturing the items like cans, pots, and automotive parts. We can see the right side of the figure how the deep drawing is done, and this is a drawing punch hold force, and it in the middle in the U shape you can see that it is a blank sheet, and the material is forcefully filled in the forcefully the metal will be pressed in the machine by the machine. Mechanism of deep drawing. The process start from the process starts with a flat blank placed over a die cavity. A punch then punches the blanks into the die and creates a deep shape. Proper lubrication is essential for the minimizing the frictions and prevent the freezing. You can see the right side of the figure how the deep drawing will be done by the machine, and the die is placed in it die will place in the middle. We can see in the mark of red here, and a drawing cavity, die face, ring, punch, drawing punch post, lower die shoe. You can see in the clearly in the figure. Forces of deep drawing. The drawing forces is influenced by the material thickness, type, and the geometry of the parts. The force must be overcome both by the material resistance and friction between the blank and die. Understanding these forces is key to the avoiding the difficult lies whiling or tearing. You can see the force between how will force will impact to the thickness of a material by the parts of a geometry. Power equipments in the deep drawing. Power requirements for the deep drawing are often higher than for the blanking or piercing. This is due to need for continuous material deformation and throughout the process. Accurate power calculations ensuring the machinery can handle the required loads. Tooling for the deep drawing. Specialized dies are required for the deep drawing designed to accommodate the specific shapes. The, the die design must consider factors like draft angle and the radii for the successful drawing. Tools maintenance is crucial for avoiding the difficulties ensuring the consistency and output of a material. Advantages of deep drawing. Deep drawing allows the effects production of complex hollow shapes. It minimizes the material waste compared to the other forming process. The process can be automated to enhance the production rate and reduces the cost. Limitations of deep drawing. Deep drawing may not be suitable for the all materials, especially blinking ones. This requires the precise control of parameters of the avoiding the difficulties like whirling and tearing. The initial setup cost for the tooling can be high, impacting in essential product runs. You can see the difficult deep drawing and understanding the manufacturing in the right side. Difficult materials not be done, limited materials only will be precise in this deep drawing. Applications of blanking and deep drawing. These operations are widely used in the automotive, aerospace, and consumer goods manufacturing industries. These are integral to producing components such as blankets, causing, and contents. Understanding this process supports the innovation and the efficiency in the manufacturing. Conclusion. Blanking, piercing, and deep drawing are crucial operations in metal forming. Mastery of the forces and the power equipments enhancing the production capability. Continuous ad- advancement in the technology and further improves this manufacturing process. I have referred from this piercing and deep drawing from the textbook Die Design Fundamentals, Materials Stamping Dies, Sheet Metal Forming, and these also involved in these also course also in process in online source in the manufacturing process and engineering materials and ASM handbook volume 14 it will be there in the online courses also. Thank you. Have a nice day.